Hi, this is Mrs. Show. Today our objective is to be able to add and subtract expressions involving scientific notation. This is Chapter 10, Section 7, and it's Day 2. So, what does this have to do with what we've learned in the past? Well, think about, what do you need when you add and subtract fractions? Yes, you need a common denominator. When you add and subtract numbers in scientific notation, predict what you will need. So since when we add and subtract numbers in fractions, we need a common denominator, what do you think we need when we add and subtract numbers in scientific notation? If you said common exponents, you are correct. So you have to have 10 to the same power. So we're going to start with adding. On number 1, when you add 2.5 times 10 to the 5th plus 3.4 times 10 to the 5th, notice that both of these numbers have the same exponent. So if they have the same exponent, you can go ahead and add 2.5 and 3.4 to get 5.7 times 10 to the 5th. When we answer, we got to make sure our answer is in scientific notation. Yes, 5.7 times 10 to the 5th is in scientific notation because 5.7 is 1 or higher but less than 10. All right, looking at number 2. When we add numbers in scientific notation, we need a common exponent. We do have a common exponent. We have 10 to the 3rd power for both numbers. So we can go ahead and add 9.21 and 2.5 to get 11.71 times 10 to the 3rd. But we've got to make sure our final answer is in scientific notation. Since 11.71 is higher than 10, we need to change it by moving our decimal point once to get a 1.171. So the beginning number has to be 1 or higher but less than 10. When I changed 11.71 to 1.171, I made this beginning number smaller. So what I need to do with my exponent is make it larger. So if I make my beginning number smaller, I have to make my exponent larger to keep it equal to the same number. Well, I only moved my decimal point once here. That means I need to make this larger by 1. 1 larger than 3 is 4. So this would be a 1.171 times 10 to the 4th. Okay, looking at number 3. I have a 10 to the 6th and 10 to the 4th. My exponents are not the same, so I'm going to have to get a common exponent. You can do this 2 different ways. You could choose times 10 to the 6th as your common exponent, or 10 to the 4th. And I'm going to show you both ways, and then we're going to decide which way would be best. So on number 3, if we do 10 to the 6th, we're going to have a 7.24 times 10 to the 6th plus, and then I'm going to have to make the second number times 10 to the 6th. Well, if I change this 10 to the 4th to 10 to the 6th, what I did with the 4 is I made it larger by 2. So if I make it larger by 2, I've got to make this number smaller by moving my decimal point 2 to the left to make it smaller. So if I take this decimal point and move it left twice, I'll get a 0.0225. Now, since the exponents are the same, I can add. When I add 7.24 and 0.0225, I get a 7.2625 times 10 to the 6th. Is this number in scientific notation? Yes, it is. So I'm good there. All right. So on the second way, what if you chose to do 10 to the 4th? That means you would have to take the 7.24 times 10 to the 6th and make it times 10 to the 4th to get a common exponent of 4. Well, if I do this, when I go from 10 to the 6th to 10 to the 4th, I make this exponent smaller by 2. So I got to make 7.24 larger by moving my decimal point twice to the right. That would be 724. So if I add 724 times 10 to the 4th plus 2.25 times 10 to the 4th, I will get 726.25 times 10 to the 4th. Well, this is not in scientific notation because this number is a lot larger than 10. So I'm going to have to move my decimal point left twice to make it 7.2625. If I make the beginning number smaller, I have to make my exponent larger, and I moved twice, so I got to make it larger by 2, which would be 10 to the 6th. So notice I'm getting the same answer. Which way was easier, using the higher exponent or the lower exponent? Yes, it was using the higher exponent because my answer turned out to be in scientific notation. So from here on out, what we're going to do is we're going to use the higher exponent. So on number 4, I have a 10 to the 5th and 10 to the 3rd. 10 to the 5th is higher. So I'm going to keep 1.234 times 10 to the 5th the same. But I'm going to change the second number so it has a power of 5. So I'm making the 3 into a 5. That means I'm making it larger by 2. So if I make this exponent larger by 2, I need to make the 1.5 smaller by moving my decimal point left twice. That's how I get a smaller number, moving left. So that would be a 0.015. Then when I add, I'm going to take 1.234 plus 0.015. That would be a 1.249 times 10 to the 5th. Remember, your exponent stays the same. You don't add 5 plus 5 because when you add fractions and you get a common denominator, your denominator stays the same. Well, when you add numbers in scientific notation, your exponent stays the same. It's still a times 10 to the 5th. Is this in scientific notation? Yes, it is. So we are good. That would be our answer. Okay, now we're going to go to subtracting. When we subtract, we still need common exponents. So look at number 1. They're both times 10 to the 4th. So we don't need to do any changing. We're going to keep this times 10 to the 4th. We're going to go ahead and take 6.5 minus 1.2. That would be a 5.3. Is it in scientific notation? Yes, it is, because 5.3 is 1 or higher but less than 10. Okay, look at number 2. Are the exponents the same? No, we have a 10 to the 12th and a 10 to the 9th. So we're going to have to make the exponents the same. So I'm going to go ahead and pick the larger exponent because I found out in a previous problem that it is easier to make it the larger exponent. So I'm going to keep the 3.45 times 10 to the 12th the same. And I'm going to change the second number so it is times 10 to the 12th. So let's see, when I go from a 9 to a 12, I make this exponent larger by 3. So if I make the exponent larger, I got to make the beginning number smaller. Since I made it larger by 3, I have to move my decimal point 3 places to the left. So here's 1, 2, add another 0, 3. This would be a 0.0071. Since the exponents are the same, they're both times 10 to the 12th, I can go ahead and take 3.45 minus 0.0071. I'll get a 3.4429 times 10 to the 12th. My final answer needs to be in scientific notation. Is it? Yes, it is, because 3.4429 is 1 or higher but less than 10. Okay, when I go to number 3, I'm subtracting. I'm going to look at my exponents and make sure they're the same. They're not the same. I have a -1 and -4 exponent. So I found out the easiest way is to pick the higher exponent. Well, -1 is higher than -4. So I'm going to keep this number 8.15 times 10 to the -1. And I'm going to change my second number so it's times 10 to the -1. Well, what do I do to -4 to get -1? I make it larger. What do I add to -4 to get -1? I add 3. So I'm making it larger by 3. So what I need to do with this number, the 2.349, is make it smaller by moving my decimal point 3 places to the left. That's how you get a smaller number, to the left. So here's 1, 2, 3. So this would be a 0.002349. Now I have common exponents. Now I can subtract the 8.15 and the 0.002349 to get an 8.147651 times 10 to the negative 1. Is it in scientific notation? Yes, it is, because 8.147651 is 1 or higher but less than 1. Okay, looking at number 4, we're going to subtract. Check your exponents. Are they the same? No, they're not. I have a 3 and a 2. So I'm going to pick the higher one, which is 3, which means I'm going to keep the 5.43 times 10 to the third the same. I'm going to change the second number times 10 to the third. So let's see, what did I do to 2 to get 3? I made it larger. How much larger? Well, I added 1. So that means I need to make the beginning number smaller, and I need to move my decimal point once. It needs to go to the left to get a smaller number. This would be a 0.1232. Now, since the 10 to the third and the 10 to the third have the same exponent, I can take 5.43 minus 0.1232. When I subtract, I'm going to get a 5.3068 times 10 to the third. Is it in scientific notation? Yes, it is, because 5.3068 is 1 or higher but less than 10, so that would be my answer. So today we learned how to add and subtract numbers in scientific notation. Your assignment is page 452, numbers 3 and 4, and 7 to 14. This assignment is on the Big Ideas website. You're going to go to the Perry Township website and click Big Ideas. Please put your answers in.